this morning. So good morning, everyone. So my talk is on embracing human-centered AI. And I'll also talk about a bit about establishing an AI innovation and capacity development ecosystem in South Africa. So before we get into the more technical aspects, it's important to draw a distinction between what I would call autonomous AI and augmented AI. So augmented AI takes a more human-centered view of AI, and it's where the AI, the machine works together with the human, and in this case, it enhances cognitive performance. The AI does learning, it supports decision-making, and also is able to discover new experiences. So traditionally, the goal of AI was full automation, and I think this is where a lot of anxiety was caused in the view that AI would replace humans and AI will take human jobs. This was, I think, historically, for a long time, the quest for AI was fully autonomous systems, where the AI works independently of the human. And in that sense, it was seen as almost a competition with the humans. But an alternate view, and this is a view of augmented AI, is to leverage the strengths of both human and machine. And in this case, the human works in tandem with the machine. And this provides a very different view of AI. And in this case, the AI, in terms of its learning and adaptation, it must also learn and adapt to the human user. And then the human user, in turn, learns and adapts to the AI. And in this way, they almost co-evolve. And then there's an establishment of trust. The human learns to determine what to delegate to the AI from experience, how to ask questions from the AI. So this interaction is almost like a co-evolution. So in this sense, augmented AI, it intends to build machines that amplify rather than replace. And this is the important distinction. So amplify rather than replace the human cognitive power. So of course, this brings about some challenges. And the two that I'll touch on is the adaptation. And this is something that's well established in the AI world. So model learning, and this is everyone's heard about deep learning and the significant and substantial advancements in this area. In this way, if you take a dynamic environment in the world, in the real world, we have noisy and incomplete observations, and there's some sophisticated deep learning techniques which can learn prediction and classification models despite this noise and vagueness or incompleteness of observations. And as I mentioned earlier, the adaptation is not just with the environment, it's also to the user. So the user might not be able to, at the goals and tasks that the user specifies may also evolve. The user might not be able to even know what or have a clear definition of their goal and task. And so it's a constant evolution, almost like a trial and error. And then the AI and the human works together to take something that's ill-defined and clarify the specification or evolve the specification of the task. There's also the evolution of knowledge, so as the machine and the user works together, there's also an evolution of knowledge that occurs, and we term this as a knowledge-driven system. So linked to that is also the notion of cognition, and cognition is about thinking, how a human user deliberates about the world. So how to represent and acquire and evolve knowledge about the world, and this is very human-centric. It's very it revolves around the cognitive process that we as humans have. So representing these processes, especially about the process that we use to discover new knowledge, is quite difficult. It's really a little bit ill-defined, and it's linked to the entire process we use in scientific knowledge discovery. It's the way that scientists think about the world, but not just the scientists. I think each human, as we experience the world, we form our own mental model of the world, and we might have different mental models between us. So if we take a historical perspective, and I think this is important to take a step back and to see what's happened, is this notion of augmented AI systems new? And actually it's not. So now you've all heard and you're worried about deep learning and the generative modeling and ChatGPTs, and so everyone that's in the fall. But many of us in the AI community also, we're cognizant of what we call the AI waves. And the previous wave before the deep learning wave was the semantic web wave, which is not really widely known about. So the goals of the semantic web was to create these intelligent software agents that was able to navigate all the information on the web, and was able to interpret, fuse, and analyze and reason about not just the information on web pages, but also all the data that was available on the internet. And this was a substantial effort in the research community. And one of the key technologies that was brought up is these concept-based ontologies. They were logic-based, so there's algorithms or logic-based algorithms which mimic our reasoning processes, and the ontologies were these kind of rich taxonomies of concepts and relationships between concepts, which provided a grounding for understanding concepts used on web pages. This provided quite a few languages, methods, and tools, one of them being the web ontology language OWL, the semantic rules language, and a whole bunch of query languages, and it provided some foundations for current research, which is still ongoing on knowledge graphs and intelligent software agents. So this really elevated what we call knowledge-based AI in the early 2000s. And the focus here was on cognition, and it was very human-centered because it's mimicking the cognitive processes almost of humans. So it's very human-centric. And of course, now there's a new wave, which is very data-centric. But as with waves, that was a wave as a start and an end. And this fizzled out like many other AI waves. And this was quite hyped up that you're going to have intelligent agents, personal agents that will automatically do tasks for you. You would not need to ever navigate the web yourself. It will go out and you could give it a task to plan a trip or to buy a product, and it would do a full transaction for you. It'll search the web, find the optimal service for you, and you'd either get a product or get a complex travel or trip booked. So when it fizzled out, there was some reflection, and it was mostly about, there was a lot of hype, and the implementation and the engineering aspects didn't follow. So there was some adoption from industry, but there wasn't really widespread adoption. And eventually that wave, the semantic wave fizzled out. So one of the key issues that the semantic web was concerned about is interoperability. And it was, how do you take all the data sets out there which were produced and hosted by many different organizations from different domains, and how do you fuse and integrate all of these across many different systems? So it wasn't just about data integration, it was about how different systems could interoperate. So this is about communication. And the semantic web was focused, these ontologies were focused on semantic or meaning, but it neglected pragmatics and social world. And this comes from semiotics. In terms of pragmatics, it says, well, we can't just define a concept in an abstract sense. It only gets full meaning when you actually use the concept in some real world process. So the context is very important. And of course, our meaning about notions is also affected by our culture, our laws, and a lot of other societal aspects. So ontologies capture semantics, but they don't always capture pragmatics. And towards the end, there was a vision of the pragmatic web, which goes beyond semantics. But of course, this came towards the end of the hype cycle, and this also somewhat fizzled out. But it's important to see that this pragmatic web vision was to augment human collaboration. Again, it's this notion of augmented AI, and this was in 2006. So where are we currently with augmented AI systems? So there are quite a few engineering channels. So so we're talking about building the next generation of AI systems, these augmented AI systems, and there's quite a bit of complexity around this. The interoperability issue, if you've got diverse data sets from different domains, from different organizations, actually fusing those data sets and doing queries across these fused data sets is still not completely solved. There's uncertainty with observations, there's vagueness in the real world, and we need these learning, inference, and reasoning techniques. And then on the software side, we need to know how to build these systems. How do you build these complex workflows? And how do you build the software that is needed for these systems? So there's been a lot of work on what systems AI, or how to build AI systems, and this is currently at the forefront of research in this area. There's about what we term software architecture. It's these reusable patterns for building software systems to ease to encode common practice. There's languages that have come up, architectural description languages for building these complex software systems. And in the same way, if you want to understand the notion of architecture, it actually comes from the how to architecting notion of designing and constructing a building. You have these kinds of practices or common architectural patterns that one can use, and then it just makes it easier to build these complex systems. So there's also some work about looking at the evolution of the behavior, the machine behavior, and also how that will evolve. So there'll be a developer or a set of developers that will design and implement the AI system. And then, of course, there'll be users, and the users need to specify or interact with the system. So there's different types of AI approaches like machine learning or rule-based. And the developer will constantly upgrade and update the AI system. The user will task the AI system. The user might specify different modes in which the AI system should work. In terms of human cognition, there's kinds of two modes of deliberation that we use. The one is what we call slow thinking, which is very deliberate, and the other one is very reactive or fast thinking. And this comes from cognitive science. So an AI system can actually support both modes of operating. So now that we've covered what is augmented AI, and I think this is in terms of future-looking AI systems, this is where augmented AI or humans, more broadly human-centered AI is going. How can AI be used for development in South Africa? So there has been some thought about this in terms of AI for sustainable development. So there's lots of potential for AI to help with development, but again, implementation has been slow. Actually, there's a lot of hype, there's lots of potential, but navigating the complexities and where do we focus our efforts. So the World Economic Forum says that we should promote external development of AI in terms of an innovation ecosystem, skills development, and creating an entrepreneurial culture to leverage AI. These are not really new, and it's kind of the obvious things. Then, so the other thing is that AI mustn't be seen as a standalone technology. It's also it's a broader ecosystem of digitalization. And so how does AI within this digitalization space, how can it be used for development? There's another new view or some insights is that it's a very fast-paced field. And of course, there's regulatory issues, which was spoken about in detail by the previous speaker. I think everyone understands the importance of AI, but we also need to worry about, there's a danger of it being used to actually increase inequality, especially in South Africa, and may result in an even more uneven distribution of resources in the world. So we actually did put together some preliminary thought piece on this in this editorial in 2020, and I just want to touch on some of the issues that we spoke up in this. I think has relevance to South Africa. So building on that, where are we at the moment, and what should we do about it? And currently, if there's no intervention, the way we expect AI to develop is that it will be developed in an ad hoc manner, and it will be constrained to specific application areas. You'll have niche technology companies, so there's a huge competition by startups and niche tech companies in South Africa to develop expertise and to dominate the AI space. And of course, then this will drive up the cost of AI, because those with the specialized expertise would dominate the market. And this doesn't bode well for holistic and inclusive development. So one way, and again, it's not surprising, is that we should establish local, regional, and national AI innovation and development ecosystems. And again, not surprisingly, skills is quite important. AI literacy and pathways. So a long-term vision of specific mechanisms with clear goals about how we should do this reskilling. And I think there's a lot going on, but I think it's not as coherent as we would like it to be. With skills, you'd also want to set up tools, methods, and platforms, which has a South African flavor, which is supported by this ecosystem. And I think that will make it significant, because at the moment, I know one of the issues is when people come to us and say, well, what platform should we use? And we're using this platform. Is it good? And I think coming up with a set of standard tools and platforms, especially for deep learning, would makes I think a significant difference in terms of then we build training programs for those platforms and tools, and then you can scale up the skills development on the technical side. There needs to be new ways of thinking about collaboration, and it needs to be agile. It's such a fast-moving field that you need to have agile platforms. And I think the old static platforms and collaborative models need to be rethought. and again for collaborating across academia, industry, and government, and an acceleration of innovation. And I think this ecosystem would cut across all three areas. So what's the potential? And here, and the way to think about it is how do we, from South Africa, how do we shape the future technological society? And I think this is important. The other option and the way things might head is to let this kind of shaping of AI and its impact on society be driven externally. And I think we need to take the horse by the reins and say, how do we want to, what would a future technological society in South Africa, and how do we develop the technology? And I think that's quite an important way of looking at it. So in our research group, we have at the University of Cape Town, we have an AI research unit. And again, this is the kind of ecosystem. So now I'm talking about a university, in one university, at UCT, for example. These are the ideas, and they're quite bold and they're blue sky ideas, but I think this is what we need to do. So some examples, we're looking at reimagining public health. We, of course, doing this with partners in the health space, using 3D AI-driven 3D digital twins, individualized health and well-being monitoring systems using low-cost wearables, looking at to what extent can AI automate or semi-automate or augment the scientific knowledge discovery process and decision-making. Also some industry links in the mining and vehicle manufacturing space. And another interesting application is we're working with a startup to see if AI can be used in the public comment and regulatory space to speed up that area. This is just to give you an idea on some of the technologies that our research strategy. And again, this is just within one university, we have the AI research unit, and by no means is this all the AI research done in UCT. It's just our unit, and we've put together things that we are going to focus on. It's pretty much tied to what I've just spoken about in the previous slide. So that's a local ecosystem within UCT, the AI research unit. And now I'm talking about a national, I'll tell you a little bit about one of South Africa's national research centers, which is across universities. And this is now at a broader scale of an ecosystem. And of course, this is doesn't cover all the AI research. It's just, there's also the AI Institute, and there's many other initiatives. So CAIR, or the Center for AI Research, it's a flagship research and capacity development program of the Department of Science and Innovation. It works across universities, across disciplines, and the idea is to build strength, South Africa's strength in AI research. A brief history, it's been running since 2011. It just started off between the CSR and UKZN. It was a government initiative by then Department of Science and Technology through the CSR. And then in 2015, we had a substantial expansion to other universities. And then also further expansion in 2019 and 2020 to UWC, Sol Plaatje, and the University of Limpopo. So this is what it currently looks like. So there's two groups. I'm not going to go through all the groups. You can look at the CAIR website. So there's two groups at the University of Cape Town. There's at UKZN, Stellenbosch, Northwest University, UJ, Limpopo and Sol Plaatje, UWC, and the University of Pretoria. And it's interdisciplinary. So we have one of the groups that has had significant impact already is the Ethics of AI group, which is at the Philosophy Department at University of Pretoria. CAIR also has tried to partner with other institutions, and one of the fruitful partnerships we have is with the National Institute for Theoretical Computational Sciences, which is a long-standing network, research network. which actually started in theoretical physics and has been expanded to the computational sciences. So we've had some impact. So CAIR, broader CAIR, and certainly not, it's the broader CAIR network, through helping government with, for example, in the speech transformation technologies, some industry partners, and then also doing some work on policy with the AU. And something that we're exceptionally proud of is the CAIR's Ethics of AI Research Group plays a leading role in UNESCO's bioethics and ethics of science and technology unit. And they were the leads on, I think, the UNESCO current ethics of AI policy. Going forward, it's now CAIR is part of DSI's decadal plan. AI and robotics is one of the 6 foundational digital capabilities over the next 10 years identified by DSI. We've managed to spearhead and establish a South African conference on AI research. So this is a broader community. CAIR plays an integral part in supporting and making sure that this conference occurs, but it's a broader South African conference, which brings in, I think, at least about 50 to 60% of the students and researchers that participate are not part of CAIR. So it's a broader. And then in August, we'll be taking a South African AI research delegation to one of the major conferences on AI, the International Joint Conference on AI, which is going to happen in Macau, to spotlight or highlight African AI research in the global community. Some lessons on ecosystems, setting up ecosystems, especially on the advanced digital technology side, is it's not easy. And we have had some lessons learned on this. And one of them was in health informatics. It was called the HEAL. And the idea was, how do you take advanced computing technologies and get them technology transfer to on-the-ground implementations. And we worked with some implementation partners, and it was in many African countries. So it was a very interesting experience, but again, this is an example and some lessons learned on a real-world ecosystem, which produced some results. What is key, and I think that we learned from this ecosystem, is that you do need standards, platforms and frameworks, and if we can get this adopted or through discussion at the national level, I think, and I mentioned this before, I think that's critical. So you have reference implementations that really substantially brings down the cost of deploying AI. One of the technology outputs that we had, and it was a very nice case study, was the Open Health Information Mediator, which is been highly successful in multiple African countries. On the organizational structure, on the ecosystem.
Prof Moodley,
yes?
Are you up soon?
Yes. Okay. I have a minute or two. Okay. I'll speed up. Thank you.
Okay.
Okay. So on the organizational side, because you want to create agile ecosystems, it should be a partnership which is driven both from the bottom up by AI innovation organizations, and also from the top down. Government can provide an enabling ecosystem for this. Okay, so I'll speed up a bit. So here's my concluding thoughts. It's hard work to set up these cross-institutional research and innovation networks. We have some examples of this in the Center for AI Research and NSTF. And we do need to have a clear vision and purpose. And I think this is needs to be provided by many stakeholders. So specifically government, for example, the NSTF can convene forums, help us convene forums to bring together key stakeholders. And the NRF, of course, can play a key role in taking AI research forward or from a strategic side. I think I'll stop there. Thank you.